Good morning. My name is Francisco Salazar. I'm presenting on behalf of my colleagues from the Instituto de Investigaciones Agropecuarias in Chile the work called Ammonia Emission from feces and urine from cows fed with or without alfalfa in a permanent grass. Ammonia volatilization from livestock excretion is one of the main gas nitrogen loss paths in the environment, which cause impact on sensitive ecosystem and indirect N2O emission, which is a greenhouse gas. Mitigation options to reduce greenhouse gas emissions from dairy cows could increase N-gas emission in feces and urine when applied to the soil. So integrate mitigation options using life cycle assessment is important to decide which mitigation option is going to be used. The objective of the study was to evaluate the losses due to ammonia volatilization following the application of feces and urine from dairy cows fed with or without alfalfa. For the experiment, we feed cows with alfalfa or without alfalfa in the diet. We collect feces and urine in these two conditions, and with alfalfa and without alfalfa. And for urine, we have also two extra conditions, which are with acid and without acid. The acid we use in order to avoid ammonia emission during the collection of the urine. And then finally, we have a control treatment with no nitrogen application. The rate that we used was 50 kilograms of nitrogen per hectare that was applied to the soil isometer for each treatment. In a randomized block design experiment with 4 replicates, we used dynamic chamber methodology for ammonia emission, evaluating for 21 days under controlled laboratory conditions at 20 Celsius degree, and emission rates and accumulated ammonia losses were calculated according to ammonia concentration by time by surface area applied. The general layout of the experiment I will show you here is we collect the lysimeter from the soil, or not to 15 centimeters, and they take them to the laboratory where we put on the top a dynamic chamber, and we have a vacuum pump that allows us to flow air from the first flask where the air and the ammonia that could contain that air is trapped. So clean air is passing through the treatment, and then we collected in a sampler, and the solution from here was analyzed for ammonia, and then estimate how much ammonia losses were lost. And here is a general view of the experiment, a setup of the different lysimeters of the different treatments. According to the results, I'm presenting the emission rate from feces and urine treatment applied to grass. You can see that the main losses are occurring during the first 3 days for all the treatments, and the highest losses at the 6 hours following the application are for feces and urine treatment without acid, which were maintained high up to the first days and then become very low up to the third, fourth days. For urine with acid, we have lower emission at 6 hours, then a peak 24 hours, and then becoming low again. And all the treatments were very similar from the day 4 onwards. Cumulative ammonia emission from feces and urine treatments applied to grassland. As expected, we have a very low emission with the control treatments, and we can see that we have higher emission in general in urine treatments compared to feces treatments. For feces treatment, there were no difference between the feces that the cows are fed with alfalfa that without alfalfa. And for urine, we observe a tendency or higher emission for the treatment that we use alfalfa. And the acid didn't had also doesn't have a difference for most of the treatments. Finally, we conclude that ammonia losses were important for loss and apply, with higher losses for urine, 33%, compared to feces treatment, that only 14%. That most of the ammonia losses were observed within 3 days following feces or urine application to soil. In feces, the inclusion of alfalfa did not affect emission, but for urine, a trend of greater losses was observed with legumes, with higher loss with the treatment of urine with legumes and no acid added. Also, the use of legume could reduce methane emission in dairy cows. For cows urine feed with alfalfa could be a greater potential for N loss which should be considered in the implementation of integrated mitigation strategies. Thank you.